number 6, that is fundamental networks. So in order to dive into computer networks in more detail, some of the basic concepts need to be understood. And one of the main basic concept is bandwidth. So what is bandwidth? Bandwidth is nothing but it is the amount of data that can be transmitted within a fixed time period. That is at a particular time, that is it can be t1. At a time t1, what is the amount of data that can be transmitted? Is it 10 Mbps, 100 Mbps? So that is meant by bandwidth. And basically bandwidth is measured in bits per second. So in the transmission media, whenever you try to transmit data, the data is always in the form of bits, and whenever the data is being transmitted in the transmission media, it is in the form of bits, and bandwidth is measured in bits per second. So there are different measures, that is, you can say bits per second, kilobits per second, megabits per second, and gigabits per second. So here if you can see, bandwidth can be compared to the number of lanes in a road. This is a single lane road. So the amount of traffic or the number of vehicles that can travel in this particular single lane is less. Whereas coming to the double lane, more number of vehicles can move, and 4 lane still more than the previous can move. So if the bandwidth is more, then uh, large amount of data can be sent. So depending upon the bandwidth only, the data can be sent. So if it is a 10 Mbps, if the bandwidth is 10 Mbps, then only at a particular instance of time, only 10 Mbps of data can only be sent. And coming to another topic, so here network devices are like on-ramps, traffic signals, signs, and maps. So what are the networking devices? Some of the networking devices are hubs, routers, switches, bridges. So these are some of the networking devices. And what is their purpose? Their purpose is to they allow the data to be flowing from one network to another network. So basically they allow data transmission, and these particular networking devices are considered like they can be ramps, they can be traffic signals, that is they direct the data to the correct destination path. Even maps also help us to direct the data to the destination path. So in the same way, the networking devices are nothing but they are like some of the traffic signals, signs, and maps that are used in the uh, particular road transport. And traveling data is nothing but it is equivalent to traveling vehicles. So how many vehicles can travel in on a particular lane? It always depends upon the number of lanes that are there. So more number of lanes means more vehicles can go. In the same way, if you are having a larger bandwidth, larger number of vehicles can move. And another basic concept in this particular computer networks is modes of transmission. That is how data is being transmitted. And basically there are 3 main modes of transmission. So what you are transmitting over here? You are transmitting the data. And whenever you are transmitting data, this data can be transmitted in 3 different ways. That is simplex mode, half duplex mode, and full duplex mode. So these are the three different modes in which data will be transmitted over the transmission media. What is meant by transmission media? It can be a cable, a coaxial cable, or a twisted pair cable, or it can be a category rating cable, or it can be an optical fiber. So basically these are the media that will transmit the data over the network. And how this transmission occurs means, uh, these are the three ways in which transmission occurs. Let us look at each one of them. And the first one is simplex. So what is meant by simplex? It is also called as unidirection, means single way transmission is possible. Only one way transmission is possible. So if you look at this diagram, here you have a sender who wants to send data, and here is a receiver. So the direction of flow or the way of transmission is single way. That is, data from device 1 is flowing to device 2. At any instance of time, there will be data flow in only one direction. Then it is called as simplex mode. And the example for this simplex transmission is the signal that is sent from TV station to your computer. So somewhere from the radio station, the signals will be transmitted, and the antenna that is attached to your cable will try to receive that particular signal. So here, once the radio has received the signal, it cannot send any data back to the antenna. Only there is only one single way of transition. If there is only one single way of transition, then you call it as simplex. In the same way, even if you can see from the TV station, it gets transmitted to the satellite, and from the satellite, again it gets transmitted to the antenna that is residing over your building. So only one will be the sender, another one will be the receiver, and data flow is on only one direction. Then you call it as a simplex mode transmission. The second one is half duplex. What is meant by half duplex? So over here, both the sender and the receiver, that is both the devices, device 1 as well as device 2, both of them can send and receive data. But there is a condition over here. When one person is sending the data, the other person will be quiet. When when the other person has received the data, then only again data transfer can occur. So here also the data flow is in one direction at a time. But here, if you can see here, at time t1, it can be any time. At a particular instance of time t1, data is flowing from device 1 to device 2. And after time t1, at another time t2. So t1 is one particular time, t2 is another time. Both of them are not same. So at time t2, then the device 2 will become the sender, and the data will be flowing in this direction. So here you can see both the devices are sending and receiving data, but at different time intervals. Time is different, but at a particular instance of time, data will flow in only one direction. Then it is called as half duplex. So uh, data flow will not occur in both directions simultaneously. And the example is, you can consider a walkie-talkie that is used by the police or some emergency communication people, they will be using. So here, once when a person is talking at time t1, the data from this particular device will reach the other device. And after time t1, at time t2, the other person who listens to the message, he will try to give his message. So it is occurring at different time. If both of them try to talk at the same time, no one will be able to hear what they are saying. So this is half duplex. The main thing which we have to remember is data flows in one direction at a time. Coming to full duplex, so here what happens? Data flows in both directions at the same time. Then it is called as full duplex. So here you can see there is device 1 and device 2. So the direction of flow at all time, that is at time t1, device 1 can send to device 2, and at that same time t1, device 2 can also send data to device 1. Then it is called as full duplex. That is, here the data flow uh, occurs in both directions. So if there is a network cable with 100 Mbps of bandwidth, uh, then data will be transmitted, that is with which is up to 100 Mbps. And the simple example for this particular full duplex is a telephone conversation is the basic example. A telephone conversation is the example for full duplex communication. So here what happens? The people will hear at the same time, speak also. And this particular full duplex technology is of very high usage nowadays. It is also giving good performance. Why? Because data is sent and received at the same time. So there is the data flow is also very fast. And broadband technology, it is allowing multiple signals to travel on the same wire simultaneously. That is also an example of full duplex. The next important concept that you should be familiar with is IP addressing. IP means I stands for internet, P stands for protocol. I stands for internet. I stands for internet, P stands for protocol. What is meant by protocol? Protocol is nothing but a set of rules that are designed to be followed. So what is meant by IP addressing? So suppose if there are a class of students, each and every student is identified uniquely with his name, and more precisely to say with his roll number. So here if we see, the roll number is so much unique and it identifies a person. In the same way, in a computer network where several networking devices and hosts are connected, networking devices are nothing but the hub, switch, bridge, all routers. These are the networking devices, and hosts are nothing but it can be a laptop, it can be a computer, a mainframe, a printer. Uh, so these components that form up a computer network. So when all these, that is the host and the networking devices, are connected in a network, how will one host identify another host? Until and unless there is some unique identification for each and every host, uh, the message or the data that one particular host wants to send cannot reach the second host. So in order to make each and every host to be identified uniquely, here they use the concept of IP address. So what is meant by IP address? It is nothing but a unique identification given to the devices in the network. So here the definition is IP address. It is a number that is used to identify a device on the network. Basically, it is used to identify the device on the network. And each device on the network must have a unique IP address. Why they should have a unique IP address? Only when they have a unique IP address, those devices will be able to communicate with the other devices in the network. So each host and also the networking devices. So not only the host, the networking devices must also have a IP address. Okay, and basically the IP address are represented in two different notations. The first notation is called as 32-bit binary number. It is represented as 32-bit binary number, uh, and it is divided into 4 octets. So here if you can see, if you count all these uh, bits, that is, bit is nothing but it can be either a 0 or a 1. So here you have 32 bits, and these 32 bits are divided into 4 groups. Each octet means it has 8 bits, and each octet is divided by a decimal or a dot symbol. Dot symbol over here you have, and it is divided. So here if you can see the representation, here this is called as the first octet, this is the second octet, third octet, and fourth octet. So there are totally 4 octets in an IP address. So this particular 32-bit number, it is very difficult to remember. So what they have done is we can convert this particular 32-bit binary number into a dotted decimal number. So another way of representing IP address is dotted decimal number. That is nothing but this binary number will be converted into the decimal number. So this 2 ones followed by 6 zeros is nothing but it is 192. It is a decimal number. So you can convert this 32-bit binary number into dotted decimal number, and it will be easy for us to remember 192.168.1.152 instead of all these numbers which are a combination of ones and zeros. So these are the two different ways to represent an IP address. One is the 32-bit binary number representation, another one is the dotted decimal number representation. So this IP address should be unique. One system can have only one IP address. No one can copy the same IP address, something similar to the student's roll number. And this particular IP address, that is the 32-bit IP address, it is divided into two parts. One is called as the network ID, and other one is called as the host ID. So there are two divisions in this particular IP address. So first part, net ID means network. It identifies the network, and the second part, it will identify the host on that network. This is the basic format of IP address. So IP address consists of both the network identification as well as the host identification over the network, and both these parts are required in an IP address. If anyone is missing, you cannot identify the particular host. So for example, if this is your IP address over here, that is 192.168.18.52. The first three octets, that is 192.168.8, they identify as the network portion of the address, and the last octet, that is 57, identifies the host. And further moving on, IP addresses are divided into 5 classes. They are divided into 5 classes. That is, it is simple to remember: class A, class B, Class C, Class D, and Class E. Each and every class has a specific purpose. Depending upon that only they have been divided. So when is Class A IP addressing being used? Class A is used for large networks. That is when there are many devices. That is, there are many hosts and networking devices in a particular network. Then Class A addressing is given. And where they are basically used? They are basically used in large companies and some also in some um, countries. While coming to Class B is basically used in medium-sized networks. That is, you can think of a university or a small company. It is where it has a medium size of network. Then Class B addressing is being used. And coming to Class C is used for small networks. That is, ISP, Internet Service Providers, they will be given with Class C. Customer subscriptions, that is Airtel or this BSNL, they will be there, right? They will be providing network internet services, and this particular internet service providers, they will be assigning Class C addresses to each and every customer who has joined. And Class D is used for it is specially used for multicasting. That and Class E is used for experimental testing. So these are the 5 divisions in IP address. So here if you can see, Class A means, as I have told you, IP address means it consists of 2 parts. One is the network ID and other one is the host ID. So here in Class A, the first octet represents the network ID, and the next 3 octets represent the host ID. That is octet 2, octet 3, and octet 4 represent the host ID. While coming to Class B, first octet and second octet represent the network ID, and the last 2 octets represent the host ID. And coming to Class C, first 3 octets represent the network ID, and the last octet represents the host ID. And Class D, as you know, it is used for multicast addressing, and Class E is reserved for testing. So in the previous example, we have seen a Class C address. Class C address where the first 3 octets represented the host network ID, and the fourth octet represented the host ID. And there is another concept, that is subnet mask. So what is subnet mask means? Subnet mask, it indicates the network portion of the IP address. As we have previously seen, network portion and host portion. So whatever network portion is there, that is called as the subnet mask. So here if you can see, Class A, we have seen that the first octet represents the network ID. So the network ID is represented by 255, and the remaining host ID which is there, it is represented with zeros. This is called as subnet mask for Class A. And coming to Class B, it indicates that the first 2 octets of the IP address are the network portion, and the next 2 are the host portion. So the network portion is indicated by 255.255, and this host portion is represented with 0. This is called as a subnet mask for Class B. And for Class C, 255.255.255.0. That is, all the host ID portion are represented with 0, and the network ID portion is represented with 255. So these are the uh, subnet mask for class A, class B, class C. The same thing it is represented in this diagram. So whenever there is a small number of hosts in a network, that is in a particular room, something like that, then what you can do is, if there is a network administrator, he can manually assign the IP addresses to each and every device. The person, this network administrator, he will be having an understanding of the IP addressing and how to assign them. So this person, suppose up to 5 to 10 devices, if they are there, uh, they can manually assign the IP addresses. But what if there are more number of devices or computers in a LAN? Suppose some 25, 50 devices are there. Then manually configuring the IP addresses to each and every host on the network can be time consuming, and in the same at the same time, uh, there is a chance for errors to occur. So instead of manually doing it, we can use the DHCP server, that is nothing but dynamic host configuration protocol. You can use this particular dynamic host configuration protocol server, which will automatically, its main purpose is it will automatically assign IP addresses. So if it is automatically applying the IP addresses, it is simplifying the job for the administrator. So that is DHCP can be used instead of manually assigning. So what is meant by DHCP? The main abbreviation or the main thing is, it is called as Dynamic Host Configuration Protocol, and basically it is a software utility, and its main purpose is to dynamically dynamically assign the IP address to network devices. And mainly by doing this, what it is doing, it is eliminating the need to manually assign IP addresses. It is reducing the time of the network administrator, and also there will not be any chances for errors. So what are the things that a DHCP server can do? A DHCP server can assign the following things to the host. So what are they? The DHCP server can assign the IP address, it can assign the subnet mask, and also the default gateway, and also it can assign the domain name, system, server address. So these are the four things which a DHCP server can assign to a host. So whenever a host is connected to a network, and the host, when it requests for assignment of an IP address to the DHCP server, the DHCP server, what it will do is, it will search for an IP address, it will select an IP address from some of the predefined addresses already, which it has in its database. And it will send this particular IP address information that it has selected to the host. And once the host accepts this particular IP address, then the DHCP server will lease the IP address for a specific period of time. This is the process that occurs in this particular DHCP server. So how you can do it in your computer is, you can configure a computer to accept IP address from a DHCP server by clicking this particular thing, obtain an IP address automatically. in this particular internet protocol properties. So by doing so and clicking OK, the DHCP server will receive the request. It will search from its database and it will provide an IP address. Once the host accepts this offer, then it will lease that particular IP address for a particular period of time. So as I've already told you, protocol is nothing but it is a set of rules. This is also one of the concept in networking. And why are these particular protocols defined? Because they help the host and the networking devices to properly communicate with each other. And these particular protocols, they are basically stacked up in layers. Many of the data models like TCP/IP and OSI data models, they will be using this type of protocol stacking in layers. The main function of protocols is to identify the errors, compress the data. It can decide how the data should be sent. It can give address to the data, and it can also decide how to announce sent and received data. And ICMP, Internet Control Message Protocol, it is basically used by devices on a network to send control and error messages to computers and servers. So if any problem is occurring in the network, that is when the data is being transmitted in the transmission media, if there is any problem like cable breakdown or over congestion, or if there is any collision of data, then this ICMP is nothing but it is a protocol, and it will alert the host by sending some messages, error messages or some control messages, so that the host will know what is the problem actually that has occurred over the network. And one of the most commonly used ICMP uh, is nothing but ping. That is a packet internet grouper. It is full form is packet internet grouper, and it is a command line utility which you can use on your own laptop or your desktop. If you are connected to the internet, it is a command line utility, and why we use it is used to test the connectivity between computers. That is, if you are the source, if you want to test whether a destination computer is connected to you or not, if you give the uh, command, that is ping command, followed by the destination host IP address, then it will tell you whether there is a connectivity between your system and that particular destination system. So basically it is used to test the connectivity between the hosts. So basically, along with ping, you may have to give either the host name or the IP address. And this ICMP, it works by sending echo requests. Echo request is nothing but it is a type of frame that is sent to the destination. So echo requests and echo replies are used to send and receive the data between two things. So basically there are 4 ICMP echo requests are sent to the destination. 4 are sent to the destination to determine the reliability and reachability of the destination computer. If it can be reached, then the destination computer whatever the destination computer is there, it will be responding with 4 ICMP echo replies. So basically 4 number of requests and replies occur. So this is an example. Here in the command prompt, he has given ping space the host name. You can also give the IP address also. So the host name is cisco.com. So then what happens? Pinging it will say with 32 bytes of data. Request timed out, request timed out, request timed out. 4 times it has come. And here if you can see, packets sent are 4. As you have seen, ICMP will send 4 echo requests. It has sent 4 echo requests, received 0 and lost 4. Received 0 means it means that it has lost. Suppose if there is a connectivity between my system and this cisco.com, then what happens is, here received I will get 4 and lost will be 0. Okay, and the lost will be 0. So here he is writing 100% loss. If not, if there is a connection, you will have sent is 4, received is 4, lost is 0, and 100% data sent and received. That is what you will get. And here you will not get request timed out. Instead, some other data will be displayed. And here if you can see 192.133, this is the IP address of the this particular host name. See, you can give a host name or an IP address also.